Good morning, everybody. My name is Peter Corless. I'm here with my colleague Minesh Patel, and we're going to be talking about real-time analytics horror stories. So buckle in because it's going to be an hour worth of scary stories. First thing I want to do is I want to talk to you about real-time analytics, just a general category, and then we'll talk to you about how it can get really scary really fast with some horror stories. And then finally, what we want to do is we want to leave you with some monster slaying techniques, how you can avoid some of the pitfalls that some of these other situations saw, and how you can fight back against some of the demons of darkness that might be plaguing your database. So first of all, let's talk about real-time analytics. When we talk about real time, of course, there's a technical term that's focused upon what a real-time database is. And we're talking more in the colloquial idea of predictable low latencies. So we're talking about sub-second to maybe single digits P99 scale latencies. So you want results that will paint in your mobile app in a user blink of an eye, or you want dashboards that'll be updated with the most relevant and fresh information without waiting hours or days for results. And when we talk about user facing, the thing is that when you were doing back in the day, you're doing internal data warehouse analysis, you had a set number of consumers that were taking a look at the reports that you were running. They're usually measured in the dozens or hundreds of people, and they were very set kind of queries per second or even queries per day. Now, with these mobile apps that have user bases of 1 million, 10 million, 100 million, or even 1 billion people potentially, you're talking about when the users are going to be driving load. And so queries per second can spike suddenly because of a stochastic event. Or, of course, there could be intraday patterns. At lunchtime, everybody's ordering. And so you need to understand what's going on during lunch hour. You can't wait till tomorrow to find out the pizzas you need to deliver today. And so when we talk about this kind of user-facing application, we talk about this unbounded stochastic load, and again, queries measured in tens of thousands to hundreds of thousands per second. The other thing that to differentiate user-facing analytics and real-time analytics from real-time transaction processing is that with real-time analytics, you're talking about range scans or full table scans. You're taking a look at a lot of data at once, where a single query could be sending a lot of different processes inside the system to fetch the data back. Aggregations, a lot of processes that need to happen in fast order. This is not just a single item update. You're talking about a lot of information that's happening at once. And then the other thing, too, is that when you're talking about these analytics, you want to be able to do very flexible indexing. There's a ton of different indexes available, let's say in Apache Pinot. And so from maybe an Uber needs geo-indexing because they need to know where every ride-share passenger and every ride-sharing car is available. Maybe it's more text or JSON. So we have structured and unstructured indexes available. And of course, proprietary to Apache Pinot is the StarTree index itself. And that we can spend a full hour just on. So the other thing when we talk about these real-time user-facing analytics use cases, if you have massive numbers of users, they're producing massive amounts of data. And so you're talking about a petabyte almost as table stakes. A terabyte is table stakes, and then petabyte is very easy to grow to over time. We see that Stripe has a petabyte use case, and a lot of Apache Pinot users are somewhere in that terabyte to petabyte scale. We're definitely hundreds of terabytes is really quickly achieved in this kind of thing. So it's probably maybe an order of magnitude smaller than your data warehouse, but it's definitely an order of magnitude or of data or more beyond your OLTP systems. And when you're dealing with data at that scale, you have to do fast ingestion. We're talking maybe 1 million objects per second, and there's a lot of real-time upserts where data hits the system and suddenly it's updated even before you've just done reports on this data the first time around, and now you're getting an upsert to replace this information very quickly. And so data freshness and data availability is a huge issue for real-time user-facing analytics. And where this is all happening is downstream from your transaction processing, from your stream processing, from your data where even you also then need to integrate data from your historical data warehouses all to get a full picture of real-time analytics. So now let's get into the horror stories here. And what I want to talk about first is a set of horror stories based upon what I call unnatural acts, right? These things that should not be, almost like a Call of Cthulhu madness, like, this is crazy. Why would anybody have done this? But of course, we all have. And let's take a look at some of these use cases. Unnatural acts come from when you've used the wrong tool for the job. And unsurprisingly, you're not getting the results you want. Now, none of this is a knock against using a tool for its appropriate task. These are the right types of data systems for the right types of problems. It's just when you're using the wrong tool for the wrong job. And so the bottom line is you tend not to get these unnatural acts if you're using a system that was designed for purpose to take care of this kind of job. So the next time, before you platoon a system that you already know, well, I've been using this system for other problems for a long while, so let me use it for this. Think about whether you should. The first use case that I've seen over and over and over again is people who have grown up using OLTP systems, and they decide to apply those OLTP systems to an OLAP problem. Just because you're familiar with the system doesn't mean it's the right tool for the job. And so I've seen this with popular SQL databases. And I've seen it with popular NoSQL databases. So it doesn't matter which one it is, it's the wrong tool for the job.
Yeah, Peter, I think you're going to talk on about this, but just to comment on that, I think what ends up happening is you kind of unknowingly, slowly, evolve into doing that. I don't think somebody sets out and says, "Hey, I'm going to use this OLTP database to do OLAP," right? It's kind of, you boil the frog, if you will, right? And so you end up in that situation sooner than you realize it.
Yes. Now, this is exactly, and this is a story that I found just searching around for this. I can't take credit for other people's stories. And so this is Jose Medina. He's a data scientist. And his bosses wanted him to use a NoSQL database that they had been using, which was working fine for their OLTP type situations. But they said, oh, the vendor is telling us we can also use this for analytics. And the issue there is that the system only scales to a certain degree, and then he starts hitting walls. And so then it suddenly became far more complex than it needed to be, and it was not designed from the get-go for aggregating data. And so this is just a common example of something that we use all the time, and it's something we love, and it works great in our original context. And you're right, over time, people start taxing it and throwing more workloads on it. Hey, it worked for X and Y and Z, so let's throw on 1, 2, and 3 as well. The second class of these is not just an OLTP system, but search engines. Search engines are wonderful. They've allowed people to get all this kind of like granular sort of analysis. And then what happens is then they start throwing in these requirements for real-time analytics on broader scales. And suddenly it becomes very memory intensive. Suddenly it becomes unreliable. Suddenly the clusters are overloading, and you can get to data loss very quickly. Now, in this particular use case, the customer fixed it temporarily by just throwing more and more nodes at the problem, just to be able to not overrun memory. But then they finally saw their monthly bill. And here's the result of what happens when you're using something not designed for purpose. You start having to really build it up in ways that it was never supposed to be operating in that way. And I want to get down now into two additional things here. First of all, take a look at what was not happening on the search engine. This is actual results from a case study where a customer was using a search engine as a real-time OLAP database. The first issue here is take a look at how quickly the search engine runs beyond a 30-second timeout. In 2/3 of the cases, the search engine just was not able to produce results in a quick enough time.
Yeah.
And then if you take a look at a system built for purpose, you're seeing 5 times up to 153 times faster P99 latencies on a system that was designed for that specific use case. Minesh, you were going to make a comment?
No, I was just calling out, acknowledging that. Yeah, that's a pretty interesting view of this, right? Where it's just all of the different types of things that just don't meet the standard timeout here.
Right. And then the other thing that this customer saw is notice how concurrency also played a factor here. So when concurrency was low enough, the search engine can struggle along and kind of get those results out. 12 seconds, 16 seconds. In fact, you can even see that in one case, they were able to get sub-second latencies on a certain aggregation with filter. But most of the time, as soon as they ran into higher concurrencies, boom, the system fell over on its head. So this is a real world example of somebody using a system for an unnatural act. Again, it's not a hit at a search engine, because search engines are wonderful. They do exactly what we want them to do in cases where they use the search engines. It's, again, this is an unnatural act when you're putting in workload on top of a system that was never designed to do. And I wish it ended only at search engines, but here's another example. People trying to use a data warehouse to produce results that you would want to throw at a real-time analytics database. In this case, again, guilty, we're not going to name anybody. This isn't a knock on any particular vendor or any particular solution. It's just using the wrong tool. Data warehouses do great. And again, if you want to store petabyte to exabyte scale data, of course you're going to do that in a data warehouse. That's exactly what they were designed to do. But if you're trying to do, again, more terabyte to petabytes workload, and you want to see what latency is going to look like, here, I actually had to use a log scale for this graph because it wasn't going to fit on a normal linear scale graph. Here I had to show the literal orders of magnitude difference of minutes that you would get on a data warehouse down to tens of milliseconds that you would get on real-time OLAP. So again, these are unnatural acts. If you can avoid doing it, please do so. Use the right tool for the job. If you're hunting vampires, there's a set of tools for that. If you're hunting werewolves, there's a set of tools for that. And if you're doing real-time analytics, there's a set of tools for that as well. Now, the next thing we're going to talk about is other real-time analytics horror stories here. And me and Minesh are going to share back and forth on some of these here. And if you're just logging in, there's still time. You can run while you need to. But otherwise, if you're staying here, buckle in, because these are some true tales of chaos here. So Minesh, why don't you take this one away?
Yeah, sure. I mean, I'm sure this one resonates with a lot of folks. Anyone who's managed a data platform or an analytic system. This is a horror story. I've got probably many variations of the same story, but the one that comes to mind was, we have a particular customer that leverages, Pinot in this case for serving their real-time use cases, for the real-time analytic use cases. Started seeing issues related to SLAs, and they were very random. Right, it took us a really hard time to figure out and narrow down what was tipping it over. Right, all of a sudden things would be working fine, and there was no pattern. It wasn't at like peak time or anything like that. But they'd start getting query timeouts on all their critical apps and things like that. It turned out, eventually after some digging and some poking around to figure out that, hey, it looks like there's some ad hoc queries that are running, and that's okay-ish, right? Like having ad hoc queries run is sometimes required. You often need to go figure out something or run a report for something as sort of a one-off, or maybe you're doing some debugging. And so the ad hoc query part itself isn't necessarily bad. It's when we don't really have any controls around what those queries are doing. In this case, they're running some pretty heavy select queries with very low query selectivity and aggregations, eating up a lot of CPU, which then impacted the rest of the cluster. So, and like I said, I've seen that story in almost every role I've played in every company I've been at. So anybody listening and that has dealt with this type of platform has probably felt the pain of that as well. But yeah, I think if you go to the next kind of slide there, we can talk about how you might prevent that horror story, or at least mitigate it if it happens. One good, sort of solution there is having a platform that has at least some sort of metrics logging, so you can get down into the queries and trying to figure out which queries are taking the most resources and at what time. So that's an important aspect, right? Just to understand where the problem's coming from. And then more of a process approach is, if you are a user that's going to be issuing ad hoc queries, generally if it's the first time you're doing it, and you don't, you've done it in your test environment and everything, but before you do it in production, obviously tools like explain plans are awesome. Running a test or breaking down the query, with the limit clause, if your system supports query, setting a query timeout, set a very small query timeout, and notch it up as you need. But those are all really important ways. And also in this particular case, not only was the query itself with low selectivity, sometimes you're running queries with expensive aggregations and things like that, count distincts and so on and so forth. So there are, approximation mechanisms that you can use, whether those are theta sketches or things like that. So certainly Pinot has some of those things built in. So yeah, I mean, the recommendation is to do those things. And then obviously if the system supports, a bad query kill, or if not kill, at least an alert, those are all good things to have in place.
Yeah, and then we're talking about automatic query killings. It could also be that, for instance, there might be some sort of automated query startup, and so you can get into this kind of condition where you have these kind of like zombie queries that you keep on killing and they keep coming back from the dead.
Yeah, yeah, it's funny. Some of these things, and you'll see this across the kind of different stories that we tell. There's some correlation between them. So I think, if we talk about, in this case, query killing, retrying, that comes up later as another theme or another story. But even in the first solution here, query metric logging or history logging, I think that takes us to the next interesting story, that was in hindsight funny, but not very funny when it was happening. So this is when I was at a pretty large SaaS company that was providing sort of this sort of data platform, the big data type of stuff as a service, right? Running massive workloads on the cloud. Had a really cool feature, which was every job or every query that was submitted would get logged, and you had a UI to kind of go and analyze that stuff. You had APIs to go and fetch that stuff. And the funny thing there was, a colleague of mine and I were just kind of joking. This is back in, in the big data days, right? So this is early Hadoop, and the hype cycle was going on, and lots of people were, jumping on that. And we were looking at some of the use cases and saying, hey, realistically, you don't really need Hadoop or Spark or Hive to solve this. It's not that big of a scale. Those specific use cases, we're laughing about it and saying, hey, they could probably solve it with MySQL or one of these transactional databases that were off the shelf. And the funny thing is, our platform was running on one of these systems, and we were saying, look, it works great. And the very next day, the thing melts down, and it had melted down because of this. It was using, not only was the same operational store leveraged to run the platform, but it was also used to, capture the query history and the logging of that. And the more users that were using the platform were also then running analytic queries against their metadata of the queries. And so, it ended up eating itself and causing a major meltdown. So yeah, we quickly learned that we should split these things off, and pushed, the query history metrics and things like that off to a proper, in that case, it was a data warehouse, which was good enough to, it didn't need real time. So it was, pushed to a data warehouse to solve that. But an interesting story there where it was a little bit of a cannibalism type of situation. Another good one, disaster recovery. So yeah, this is another, funny now, not so funny during, and sometimes I get a little bit of PTSD off of this one. A similar situation. I was at another company, and we were at our company offsite. And then, by the way, just in all my roles, I've been, customer facing. So a lot of these are real world scenarios where one of our clients or one of our partners had hit a situation like this. And in this case, we were at an offsite, enjoying ourselves, just socializing. I don't have my laptop. I get a phone call from a senior director at one of our strategic customers at the time. Really nice guy. He doesn't really call often, so I figured it was important. So I picked up the phone, and I think, paraphrasing here, but it's something along the lines of what that first quote is there. It's like, hey, Minesh, I think we're having a problem, right? I'm like, oh yeah, sure. What's going on? Yeah, I'm not sure yet, but one of the queries we're running or one of the jobs we're looking at, seems like the source data is not returning anything for one of the tables. And I go, huh, why don't you, just go ahead and engage support and we'll start to look at it. He goes, yeah, sure, let me do that. And I'm going to do some, further analysis and confirm. Calls back a few minutes later. Yeah, looks like, not just that table, but all of our core tables, they're empty. And I go, what do you mean empty? Yeah, we looked at it, and the underlying cloud object store is not returning anything. I go, oh my gosh. So it turned out somebody had run a command that was, in our case, supported in open source, but not so much, well tested or battle tested and on the cloud yet. Ended up basically dropping a bunch of data. And so yeah, that was scary because this was a core part of their business. And so they had a major escalation on their side. We even involved, the cloud partner that we were working with. The cloud vendor in that case said, sorry, there's no way to get it back up. In hindsight, when you think about a situation like that, as the vendor in that scenario, it's easy to imagine a customer would be pretty frustrated with that and potentially, end the partnership, right? But to the credit of the partnership that was built here up to that point, it was the comment I got back when I was apologizing profusely about what had happened, was, hey, look, it's our bad for not having proper backups and proper mechanisms in place to prevent these types of things in production. Sure was, a gap in the product that in your product that exposed this, but it could have been somebody doing something else, unexpected or stupid. So, really felt good about their mindset and the spirit of partnership there. But like I said, there's a lot of things that could have happened that we could have done to prevent this, both on our side, on the product side, but yeah, on the customer side too, in terms of, ensuring you have replicas and backups and things like that. And, the good news, at least for what it's worth in this story, they were able to regenerate those tables from the raw data sources that they had. It cost quite a bit of compute resources to have it done as quickly as possible. But the company I worked for obviously, helped, at least for the cost that ran on our system, was that was given out pro bono. But yeah, I mean, it was a really scary story when all of a sudden your data's gone. So yeah. Yeah, Peter, you want to touch
Yeah.
on this? Yeah.
So that's the thing. What if your backups are all gone all of a sudden? But let's take a look at what happens if your entire cluster is gone. And by that, I'm talking about data center fires.
Oh.
And they do happen. I remember clearly I was at a different company, but there was the OVH cloud data center fire in France. And that took out about 2%, one server in 50 in the French .fr domains, top level domains there. The crazy thing about that is that that was the time when a lot of customers found out that their backups were stored at the exact same data center. So you really want to think about your disaster recovery. How disaster proof are you? Now, fortunately, this customer, in the case I'm talking about, they chose their distribution of their system over 3 different data centers, at least separated by 100 kilometers in Europe. So they actually had 2 working production data centers, and they were able to fail over in that case gracefully. And the other 2 data centers, with only 2/3 of the node, were able to keep up with their backlog of work. And so it was a little bit scary in terms of their latencies and making sure their SLAs were being met, but they were operational. And a lot of customers really need to think about that. Have you ever tried to see what happens if you do take out a data center and whether you can meet your production goals? The other thing is that this is not as rare as one would imagine, because there have already been 6 data center fires in 2023 alone, and about 21 data center fires, or even a data center explosion since 2014. The craziest headline I share here underneath Elmo, which talks about a Lincoln, Nebraska data center fire, which actually brought down 911 services, so they couldn't even call the fire department to come to the data center that was on fire. So that's a true life horror story. So you really need to think about your disaster recovery plan, and probably put a little bit of fire drills on top of it to make sure you don't wait until a disaster actually hits you to see whether you have a resiliency plan that's actually going to work.
I think it's an important point there, because I think one of the things that the evolution of analytics in general has always been sort of this thing that isn't necessarily tied to live use cases, and now it is, right? And we're seeing that more and more, especially with user-facing analytics. The analytics are driving either user decisions or other application and machine decisions, and therefore becomes a critical part of what your business is. And so, yeah, that's actually very important.
Yeah, now I'm going to toss this back to you, Minesh, because I think you can talk directly to this one.
Oh yeah. So another fun story, if you will. This is, again, I was at another company, and I've been customer facing and I've led teams, and this is as a solutions architect leader at another fast pace growing early stage company. And if anyone's ever worked for one of those companies, you probably can think about and potentially cringe about all of the things that everybody knows you should not be doing, but just do, just to get things done fast. And in our case, our solutions team had access to our production database, not everything, but for certain things, granted. So definitely was quote unquote secure. So it wasn't a security thing, but it was more of protecting the SLA and availability of our production environment. And so in this case, what we were doing is using that database to make customer configuration changes, right? When requested by the customer. And I'm about to get, I think, on a plane, and I remember getting buckled in and hearing the announcements to turn off your devices and blah blah blah. About to power off my phone, and my phone rings, and it's one of my solutions architects. And I go, okay. And he goes, hey, so yeah, I think might have a bit of a problem. I'm not sure. And I go, okay, sure. What's going on? He's like, well, I was modifying XYZ customer's cluster configuration, and I made a mistake, and I wanted to delete that config so I can add a new config. And I go, okay, sure. He goes, yeah, but notice the delete command ran, much longer than it usually runs. And I go, okay, all right. And he goes, yeah. So then I went and checked, and yeah, it deleted pretty much all the configurations. And I thought, well, for this customer? He goes, no, I think I deleted all customer cluster configurations. And I go, oh my gosh. And so I think, obviously there's safeguards and best practices to this stuff, and, put a limit clause and there's like things like that. But in the heat of the moment, you're multitasking and you're trying to get things up and running for a given customer. It's very easy to see why this happened. But the other funny thing is I'm on the phone with him, and then I got to get off the phone with him, and I call, our head of engineering to inform them that this has happened, and then we need to pick up something from the recent snapshot of our replicas and so on and so forth. In the middle of all of this, the flight attendant is, starting to get pretty upset of me on the phone while the plane's now, sort of making its way down the runway and things like that. And she's like, oh, you got to get off the phone, sir. And I'm like, hold on, well, all of our customers can fix. She's like, I don't care. So it was just funny, the situation where I'm just freaking out on my side, and she had a whole different agenda of just getting me off the phone. But anyways, long
Yeah,
story short, there, it was a crazy one, but we did one small mistake, at least at that point in time, that the user felt like was just a small thing, cascaded into a whole lot of effort to bring things back on board, and then also go and explain to our customers why they couldn't launch their clusters for that hour or whatever it took us to get everything back. Was not fun.
Well,
And
I'm glad you didn't end up duct taped to the seat, right? That's how they'd handle you these days.
yeah, exactly. Exactly. I can for sure, you know what, one thing that it did do was a forcing function to get, a nice portal and UI built for my solutions team, something I had been asking, the engineering team to prioritize. But you're in a startup, you're balancing getting features out the door that impact revenue and customers versus internal tooling. But this got the internal tooling done, practically overnight. So yeah.
All right. So talk to me about evil ETL.
Yeah, yeah. So not only analytics, but getting the data into your analytics systems is an important part of the journey that the data makes. And we touched on earlier. You talked about bringing queries, retrying queries and bringing systems back to life and so on and so forth. Along the same sort of vein there, um, this is I spent some time at a ETL automation company. Really awesome tool. Did a lot of cool things with, being able to make things easy for people to integrate from sources to destinations and so on and so forth, create data products and all that cool stuff. And in making things easy, obviously resiliency is really important. In this particular horror story, was funny because I'll talk about I'll talk about the last bit first, and I'll come back and tell you what happened. We had a very good partnership with the particular company. They were using us to do a lot of things like build operational dashboards and stuff like that their CFO would use for forecasting and cost and so on and so forth. We get on our weekly call, which is usually very friendly. We talk about cool things they're doing with the product and so on. And this time their VP, who joined, I think, when they first bought the platform and had once in a while, was on, which was rare. We all said hi to him. No one was smiling. I get a Slack ping from one of the users that I've been working closely with, um, kind of apologizing in advance and said, I should have given you a heads up, but blah, blah, blah. And I go, oh, what's going on? Anyways, they're like, hey guys, so yeah, we had this board meeting. It's a publicly traded company, right? And it was an internal board meeting to prep for their announcement to the street on earnings and things like that. And they go, well, realize that our sales forecast numbers were way off, like 10x or something like that. I don't remember. It was a multiple fold more than what the reality was. And somebody caught it, realized the numbers didn't look good, started digging into it, and realized that our tool that was moving the data into their data warehouse was duplicating data. And it was a big shock to us because never heard of that. If that was a bug, that would be a really, really nasty bug. Turned out it was their data warehouse system that wasn't reporting errors back properly. So we were retrying. It was reporting an error, which was reported as a transient error that we would then retry on safely. But the data warehouse was actually throwing false negatives up. And so it was actually ingesting the data and throwing an error. And so we kept pushing the data over and over again, which inflated the, particular values in one of the tables. So yeah. And it was silent too, because it was a retry. Nobody, there were no alerts. There was no, sort of fatal errors. So the thing just kept going. But yeah, it was pretty bad because of the level of escalation I got. Yeah, that was in that scenario. It's when something is supposed to help, ends up hurting. So you got to be careful with those things for sure.
So related to that, so that's duplicating data. And here's the exact opposite, where the same data might be represented in multiple different ways. And in fact, we just had, I'll get back to this example in just a second, but internally we had it where we were doing web analytics, and it turned out that we changed the title on our homepage and the meta description a couple of times this month. And so we had 3 different roll-ups of the homepage, under different titles and subheads. So a lot of times you have to take a look at your data and your metadata to make sure it's matching. And here's an example just of all the different ways that the United States could be represented in a menu pick on a pop-up on a web form. And of course, these days, people are ingesting data from multiple different sources, sometimes internal, sometimes from their partners and downstream customers. or I should say upstream customers. And so you might get data in all sorts of different representations. And there may be even some people who, strangely enough, are still providing people a free form fill-in. So you can get it in any format. Of course, you also have the possibility that you're dealing with international partners, and they may be representing that data in a completely different format. And so you can see Estados Unidos or Estados Unis, right? So depending upon where you're getting your data from, you need to harmonize and make sure all of this is represented in your database the right way before ingestion, hopefully. Because if you're ingesting objects at a million per second, doing it as a cleanup job on the production server is going to be a hellacious task. And I think this is a problem that we've all seen, especially these days in a world of cloud economists, where for whatever reason, somebody left a cluster running, and they may have had, a job there running at one point that actually needed to run, but they forgot to take it down. And I think that Minesh, why don't you talk about some of the things that you've seen happening with the overrun of costs in clusters these days?
Yeah, classic problem. I think in the data world, obviously, all different sort of aspects of leveraging the cloud. You can hit this in the data world, particularly a lot of experiments, right? A lot of people testing things, experimenting either with the data modeling side of it, the technology they're leveraging, so on and so forth. And the beauty of the cloud is how easy it is to spin things up and run those experiments that are very valuable for productivity and getting things out the door. The downside, of course, is, hey, you did something, either one of two things, right? You spun something up and forgot about it, right? And over a weekend or a week, and you went to vacation, you come back, and all of a sudden there's this fat bill sitting on your boss's desk for something that it wasn't supposed to cost that much. The other side of it is also maybe not sizing things properly. So you did something that was too big, or too costly. You weren't using the right instant, so whatever those scenarios are. So I've seen a whole mix of those things. Like I said, I was at a company that was doing only big data in the cloud. And so, those were giant machines sometimes, because you're processing and churning through often hundreds of terabytes to petabytes to more of data, right? And so you need that compute power, but leaving that on even for an extra half a day or a day, could run into the tens of thousands of dollars, right? So that is something I'm very, very familiar with. I've seen that, and I think there are strategies here as well. A lot of the cloud vendors themselves have now tools and mechanisms to send you alerts and messages when something's exceeding certain cost boundaries. You can set limits.
Mm-hmm.
A lot of the tools out there now that are stateless, right? When I say stateless in the data world, you have stateful systems and stateless systems that take advantage of persistent, just separation of compute and storage. Super easy to set up auto scaling and things like that on those systems. So that's important. For systems like real-time analytics, where you're constantly receiving events, I'm talking about in production, right? Where you're constantly receiving data that's coming off a stream, and you have constant sort of necessity for people to have access to that information. Those are more stateful, right? So you cannot easily, well, you can theoretically separate compute and storage, but you pay the price typically when it comes to performance, right? A nice new feature, and so Pinot generally is stateful, so you kind of need this thing on. One nice thing, just to kind of talk about it and give it a plug here, is Pinot's ability to do tiered storage to kind of give you the best of both. So yes, you do need some compute framework up and running, but how big that has to be can actually, now you can gain the trade-off of saying, hey, look, for data that's not, that I don't need, millisecond latency on, I can actually put older data and have that offloaded into like a cloud object store, for example, automatically. So yeah, I mean, like I said, I've seen a lot of these stories. I think there's tons of ways you can approach it. I think it just being mindful of that early, so that it doesn't come bite you when you forgot about it.
Yeah, and I think it's really important. Like, when you talk about, let's say, an Apache Spark, somebody will spin up a cluster, run some analytics, and then they'll get their results and then blow away the cluster, right? That's very different than when you're talking about a Pinot, which has the persistent servers on the back end. The only thing that you could really auto scale there might in real time would be, let's say, the brokers on the front end, right? But that might help with your queries if you're having like a very quick ramp up in query load. But obviously, I don't think anybody's going to be going from like 100 terabytes to 200 terabytes of data. That kind of data. It's like the back end data that you're running against is not going to
Yeah,
scale at the same rate.
that's right. One thing we do support now is, we have this kind of sidecar framework, and probably getting off topic here a little bit, but just to mention it since you talked about it, which is called the Minion framework.
Yeah.
Framework is awesome at like kind of you have your online sort of Pinot system that's serving queries and ingesting data real time and all that nice stuff. You might have batch systems that you want to augment that with. So pulling data from a cloud object store, a cloud data warehouse or something like that. The Minion framework is actually awesome at doing that. Also doing, like, again, like I said, we're getting off topic, but resizing segments and stuff like that. That runs, and that is actually can be auto scaled, right? Because
Right.
very similar to what you just mentioned about Spark and Hadoop jobs and things like that, where they run in this sort of pipeline fashion.
Hmm.
The Minion can actually then scale up automatically based on the data volume and what you're trying to do, and then automatically scale down.
Exactly. So when you have no minion tasks, you don't need to keep those clusters running. Yeah.
Yep. 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 Yep.
All right. Let's see what else we got here in the horror stories. Okay, now we're going to turn our attention to methods to slay those monsters and to stake those vampires. So one of the first monsters we see is what I call the boss's nephew. This is somebody who has more access to privileges than they have common sense. And so you want to take a look in your organization for, is there an individual or set of individuals or team that's coming in sideways for to what you're trying to do, and they're the people that are specifically adding the load in ways that the overall team might not appreciate. And Minesh, can you think of examples of bosses' nephews from your own past?
Yeah, yeah, and it's hard to kind of point specifics here, but generally you've seen that where maybe how the organization evolved and grew from a small teams to larger teams. People get grandfathered into having certain access, and as processes and organizational structure is, like I said, evolves, they may not need that anymore, but don't necessarily want to let go of it. And so it's a sensitive subject sometimes, right? Depending on what that is. And I think at the end of the day, if that access was initially granted for, you know, enabling certain things, right? Enabling the business to move forward, make decisions, take action, so on and so forth. And there are now mechanisms in place that allow you to achieve the same sort of outcomes without that unfettered access. Then your approach there is transitioning those teams users off into the newer, more safeguarded systems that prevent carte blanche access. Now,
Right.
like I said, everyone is going to say, yeah, that makes sense, in other heads, but to actually do that, might require some top down, might require some coercing, but it is absolutely important, to make
I think
sure.
that this also calls back to your point about how it was finally getting the outage of the config table wipeout was the argument to finally get the dashboard so they could do it automatically from a web control panel. I think that was a great example of how you can control your access control.
Yeah, exactly. Because it is going to break. Someone is going to make a mistake. And so getting ahead of that is going to be better. Yeah.
All right, let's see what else we got next here. Okay. Now, given that we talked about those data center fires, you don't want to wait until you have a data center fire to see if your playbook is actually up to date. So you're going to want to play with these ahead of time. And I think this is it'll not just for your own internal team, but to go over with your vendors, also to go over with your data consumers. They need to have acknowledgments about if there's an outage. The last thing they want to, the last way they want to find out about it is by going to down detector to see that your stuff's on the floor. So you want to you want to have a full scope of communications in your disaster recovery playbooks. And it shouldn't just be an academic exercise. You definitely want to, even I call this the torpedo test in a proof of concept. When you do your performance cluster testing, rather than just getting a benchmark of maximal performance, what if you run a cluster and then take out a node? What happens in terms of quiescence and time to quiesce for the cluster as it gets into a degraded state? Take out a second node. If you're testing a 10 node cluster, how many nodes can you safely take out to still meet the SLAs? And you don't need to wait till production. You can put this into your thinking ahead of time, even in, like I said, even at the POC stage. Another thing is when I talked about that data center fire before, it turned out that the database that they had in production didn't go down. It was able to operate with 20 out of 30 nodes in the cluster, but they actually had a single point of failure from one of their cloud providers' services, and that microservice was unavailable during that time. So they needed to do a lot of scrambling to deal with that one single point of failure where everything else happened to be actually running. And again, make sure that you keep these playbooks in really up to date. Make sure that they reflect the current state of your topology. Minesh, do you have any other words of actual experience around this here?
Yeah, this is an important one. I think just one perspective on it is you have, obviously. So here's the kind of the variables at play here, right? Typically with these systems, they're large scale distributed platforms. There are, an infinite number of variables at play of what could go wrong. So to build, to test for all of that and QA for all of that before you're in production, it's impossible. Obviously, you're going to do as best as possible in terms of coverage and continue to expand the coverage of your testing. So it behooves all of us to then therefore be prepared for this, disaster. When you say disaster, I mean, that could be disaster. It could be, production outages. It could be unforeseen issues, right? So I think having that same mindset of understanding what can go wrong and how the CS system can react to that, and then what is the action plan then when those things happen, and having all of that stuff be available, and I think the other important thing is having everybody be aware. And I like those first 3 bullet points there that you have there, because your staff, on-call staff, engineering staff, support staff, whomever is going to be a stakeholder in this process, be well aware of what the latest and greatest, versions of these playbooks are. Those things can go stale, they can be hard to find sometimes. And so when, on a Sunday, early 5 a.m. when something's busted, trying to find the people that know, what to do can create a lot of angst and pain, and, obviously customer dissatisfaction, revenue loss, whatever, right? Like, I think that is important. I want to call out what you have here, right? Go over with your vendors and your data consumers. And I think that's something that often happens, when you before you sign the contract, to get the boxes checked so that the security team and procurement team is all good, before you can proceed with a vendor, or your data consumer, same thing. When they onboard those initial use cases, it's, we kind of go through that process. But having this as a checkpoint that may be something that you do periodically, is important, right? Because I think, again, having your vendors understand what your process is. Now, their process may or may not align, but as long as they can support you in your process, through that, I think is really important. And I think it's something that's said a lot, but I don't know how often it's done. So I think in this world, there are so many players in that sort of chain, right? You have, whether you're in the cloud or you're on-prem, you have multiple vendors at the entire chain of what your end product and application look like. It's really important to have this kind of vetted out across, that entire chain. Yeah. I mean, I think I've seen companies do it really well. I've seen others not do it so well, and it's usually when that disaster strikes that you go and fix all these things. And the unfortunate reality of this is people have lost their jobs because of this, right? And not having this in place, or others have been promoted and become heroes because of how they've had their ducks in a row. So um really
Yeah.
important one.
One other best practice I'm going to toss in here is also make sure that, for instance, if this is going to be a customer facing outage, that your social media team is also considered part of your disaster recovery play. Because they're going to be getting all the customer issues immediately. You can just imagine how Facebook or Twitter are just going to go on fire.
Right.
And again, the last thing they want to do is find out that the system's down because some customer's telling them that it's down because of down detector. You want to make sure that you're proactively telling your social media team, here's what we know as we know it. This is what you can say. This is what you can offer in return. So is it going to be an hour, a day, a week, or you just don't even know how long this outage is going to be? But the social media team needs to do that because they may need to get all hands on deck and bring people in from their vacations or wherever to man those social media lines. So again, think about this as an overall company response strategy, not just as an IT team taking care of an internal problem. So another thing, talking about teaming, it is incredible how a really put together A-plus player team that are all working together can handle these kinds of issues because they have the experience. They're not all panicking because it's the first time they've all been through the fire drill. It also, I think, behooves you to turn your team into A-plus players by giving them the tools, the strategy, the training to be able to handle these things. Give them some forethought so that you do have that A-plus team around you. Any comments, Minesh?
I mean, this is no need to add any further comments to this. This is spot on.
All right. Well, we have the spirit of Steve Jobs looking right at you right now, right? And
Yes.
speaking about a team of A-plus players, this is where we get to talk about the team that we have here at StarTree Cloud, an incredible team that Minesh works with day to day that's making sure that your systems are secure. We have the enterprise class features that you need to run in production, world-class support, 24 by 7. And I, as a marketer, get to have the privilege to sit in and watch these guys solve some of these problems in real time. And I'm telling you, the brain power we have here is just incredible. And Minesh, why don't you take a little bit of time to shout out to your team and tell the folks that are listening some of what you guys do on a day-to-day basis. How are you guys like the Avengers or superhero team?
Well, flattered by that analogy, but I do think my team for sure. I mean, some of the things that we do, right? And even before we have a partnership, with a customer, often they come to us and StarTree as open source users of Pinot, or perhaps some similar technology, and are struggling with real problems, challenges with being able to serve either user-facing analytics, or the need for real-time, whether it's internal users or external users or whatnot, real-time analytics for mission critical decision making capabilities. And on the sort of the pre-sale side, if you will, the solutions architects that work with the folks that are looking at us as a potential solution, we'll work closely with them, identify what those use cases are, help tune things, help provide guidance and support on getting, how do I size this, a variety of different things. The goal being helping them be successful. And then, my team, as we onboard customers, there's it's hard. I mean, there's a lot of nuances, if you will. Being it's you're driving a Ferrari here, right? On a racetrack, and every little millisecond matters. So how you tune it, how much air pressure, tire pressure, air pressure in the tires, your gauges, your valves. You got to check everything and make sure the thing's tuned up perfectly. The beauty of StarTree Cloud is a lot of that is automated, so it takes away the burden of having to think through those things. But at the same time, every customer's use cases are very specific. So therefore, my team gets involved in working closely and partnering with the customers to, and ensure that they can get onboarded, but then continue to see success with their
Right.
use cases and additional use cases that might come up.
Right. But the stakes are really high. I mean, the issues about how do we integrate this with our public key infrastructure? How do we make sure it integrates seamlessly with our data pipelines? There's a lot of moving parts. And I think
Yeah.
one of the issues that a lot of people get into with open source and these big data platforms is that their teams can only scale so far. And then they're running a lot of these different, and they're very heterogeneous data systems internally. And finally, they go like, you know what? We've got to the scale. It's working, but boy, we really need the expertise. And I think that that is the critical difference that your team, our team here at StarTree brings into this is the specific expertise around Apache Pinot and how to keep it running at scale.
Yeah, absolutely. I mean, we've got folks that have done this at your at a very, very massive scale and have seen this push the boundaries with the platform and the technology, and so it's really cool. It's great to have that as a support system here that we then extend to our customers. So it's awesome.
All right. So those are some of the scary stories that we have. And on behalf of Minesh and myself and all of us at StarTree, we want to thank you. Hope you have yourselves a wonderful, happy Halloween. Stay safe and have all the candy that you can stomach tonight. Thank you, everybody. And thank you, Yarden, for putting this together for us. Take care.
Thanks.